Okay, class, in this video, we're going to learn how to sketch angle measurements. And we had you do a warm-up. So in this warm-up, notice how I have the answers, but for number 4, I didn't know if it was going to be 270 degrees or 90 degrees because I could have gone that way, or I could have just talked about the angle here. And that's the whole idea behind why we are going to sketch angles with so many different definitions, because we don't want to leave everyone questioning what could be the option for the angle. So before we do this, we need a bunch of vocabulary for sketching. So first off, the vocabulary we have listed here, we're just going to go through, we're going to define them, and then I'm going to show an example of it working all together. So standard position is angles created with an initial side on the positive x-axis. Then we're going to have something called a rotational angle that gives direction to the angle movement. We also have something called initial side, which we just previously mentioned. And the initial side is the start of the angle rotation. So the starting side, we're going to call it. Quadrants is a name that you should already be familiar with. Quadrants are each section of the coordinate plane, and it goes counterclockwise, just as a reminder. So you have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Terminal side is going to be our ending side of our angle. And reference angle is always between 0 degrees and 90 degrees, or 0 and pi over 4. Remember those radians. And that's always the distance between the x-axis and terminal side. The reference angle always needs to be written in the drawing as well, because we need to know where to do the calculations from. So for example, if you were drawing an angle, you would need that initial side on the positive x-axis. We know that this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and also 360 degrees. So if this is the starting, our initial side, then we're going to have movement, and let's say we're drawing an angle that goes this way. So this is a positive angle, it moves this way. But notice how we don't know how big this angle is. That's why we need something called a reference angle. And the reference angle goes right here. So for example, if we said the reference angle was 20 degrees, we would know that the angle that we just drew is 160 degrees. If we are going this way positively, that means this way is negatively. So this would be negative 90 degrees. This would be negative 180. This would be negative 270. So the motion of the angle and the rotation all really matter. That's why you must have an initial side every time. You must have this rotational arrow that has an arrow at the end of it showing you direction. And you must have a terminal side along with the reference angle. So now we're going to put this into effect and practice a couple. So for number 1, we need 60 degrees. The first thing we're going to do is go around and say, okay, this is 0, this is 90, this is 180, this is 270. These are all things we already know. So if I want to do a 60-degree angle, I'm always starting here. Draw that nice and dark. And I need to go to 60. Well, 60 is in between 0 and 90, so you're going to put it somewhere here. And again, you want that motion because I want to go positively. It's possible that someone could have gotten confused and went that way, which would make that a negative angle. So I'm in quadrant 1. And my reference angle is the distance between this and the x-axis, which in this case is just 60 degrees. It's not the case every time that this is the reference angle. We're going to try another example. We're going to do 2. And number 2 is 130 degrees. So again, we're going to write the degrees around because we know it's 0, 90, and 180. So 135 must be in between 90 and 180. So that means we are in quadrant 2. So again, real dark initial side. Arrow of movement going positively. We're going to stop somewhere around here because 135 looks like it's around here. We're going to draw the terminal side. But remember, I just said it's around here. If you didn't have any numbers on here, you can't guess that that's 135. You need something called the reference angle, which is right in here. So to find that, it's going to be 180 minus 135. And when you do that math, 180 minus 135, you end up getting 45. So we're going to draw that in right here as a reference angle. We're going to write 45 here. I'm going to make you do 3 on your own. I'm going to jump to number 5. Number 5 is negative, which means we're going to have a different motion. So instead of going this way positively, we want to go backwards. So if this is 0 and we go backwards, we know this is negative 90. Negative 30 is in between 0 and negative 90. So here's our starting side. And we want to move this way only 30 degrees. So the distance between the x-axis and the terminal angle is a positive 30 degrees. So we're going to write 30 degrees right in here, even though we know that's going negative 30 direction. And we're in the 4th quadrant. We're going to also look at number 6, because number 6 is a much bigger number than we're used to working with. So we're going to start out and label each degree. So we got 0, we got 90, we got 180, we've got 270, we've got 360, but that's not enough. So if I had started my initial side here and I went around once, I only have 360 degrees. So if I did 690 minus 360, I have 330 more degrees to go. So I'm going to do just that. I'm going to go another 90, another 180. 330 is around here. So this is now showing the motion of going all 390 degrees or 690 degrees. Think about it as like a skateboard move. You're going around multiple times to get a 690 on a skateboard. So we have our ending side. We have our movement arrow. The only thing is, if I'm looking at this picture, I have no clue I went 690 because I don't have a reference angle. So we're still in quadrant 4. To find that reference angle, if we went 330 and this was 360, we do 360 minus 330, and we will know that this is 30 degrees.